Namaste and welcome back to the DSA class. Today I'm going to be solving a question which is again commonly asked in Microsoft. Now what is this question? The question is to find the maximum AND pair in a given array of integers. What does this question even mean? Let me show you. Alright. So let us assume guys like this, I have an array with me. 16, 9, 6 and 13 are the elements in the array. Obviously, you can do AND operation between multiple pairs of elements. For example, 16 AND operation can be done with 9, 6 and 13. 9 with 6, 9 and 13, and obviously 6 and 13 also you can do. But if you look at this, the result of everything I am showing, the highest result is that of 9 and 13, which is 9, and the maximum AND pair is nothing but 9 and 13. In other words, the result is 9. So you are not expected to give the pair, you are expected to give the result. So 9 and 13 is 9 and that is the highest value. I hope you are able to think. Now a very easy way to do this is by making use of the brute force approach. In the brute force approach, this is the array that I have with me, right? What I will do is I will just create a variable called as result. Let us assume the name of the array is AR, right? What I am going to do is I will have I start from the first element. I will make sure I goes to the second last element because you have to always do pair operation. I hope you are able to think. So what I will do is I will tell like this, for I equal to 0 to n minus 1, and then I will have j, and j will be positioned always one step ahead of I, and j is going to help find the pairs. I hope you are able to think. And inside that I will tell for j equal to 0, and j should go till the end. So I will tell n. And what should you do? Just check if in case the ith element, if you do AND operation with the jth element, I will check if it is greater than the existing value of result. If it is greater than the existing value of result, it means I have found a higher value, and that must be my maximum, and that is what I will do. I will update result. I hope you are able to think. So if in case you keep doing this, obviously by the time you finish all the iterations, result will have the value of the maximum AND pair, and in this case it is going to be 9, which is nothing but 9 and 13 put together. I hope the brute force approach is clear to you guys. Now when it comes to time complexity, it's quite straightforward. You have two loops, right? If you have two loops, one within the other, then you could say it is big O of n square. Now n square is never good. Is there a better way to approach this problem? Certainly there is. And if you are making use of AND operation, naturally even the hint or even the solution would lie in the bits. Well, what does the bits tell us about how to approach this problem? Let me show you. Before I proceed and tell you guys how to approach this problem, I want to make 3 observations which is going to help you better understand my approach. Observation number 1 lies in the truth table of AND. Clearly one can notice that the result will be 1 only if both the operators or both the bits are 1. I hope you are able to think. Only if both bits are 1, AND is going to be 1. In all other cases it will be 0. Number 1. Observation number 2 is, let us assume I have 1, 0, 0, 0 like this. I want to check if the leftmost bit is set or not. How will you check if a bit is set or not? By making use of a mask. And in the mask, the bit I want to check whether it is set or not will be made 1, everything else will be 0. And if I apply AND operation, if really the bit was set, I will get non-zero like this. How are you able to think? But let us assume I had all zeros. I want to check if the leftmost bit is set. Now in my mask, the leftmost bit will be 1, everything else will be 0, and if I apply AND operation, clearly you can see it is equal to 0. If it is equal to 0, it means that it is not set. If it is not equal to 0, it means it is set, and this already you guys know. I am just refreshing your memory. Observation number 3. Look at this. I have 2 binary sequences in front of me. Just by looking at it, can you tell me which one is larger? Clearly all of you selected the first one. And why did you do that? You looked at the most significant bit and you saw that the first number's leftmost set bit is closer to the MSB or is at the MSB in this case than the second one, which is further away from the MSB. The closer the leftmost set bit of a number is to the MSB, higher its value. The more away it is from the MSB, lesser its value, and this is simple common sense because that is 8 in decimal, this is 4 in decimal. I hope you're able to think. Now let me give you one more binary sequence. So 1 0 0 0 and 0 1 1 1 like this. Now just by looking, can you tell me which is higher? Now some of you will pause for a moment and think, because the second one has more number of set bits than the first one. Clearly one may think that the second one will be a higher value, but you are absolutely wrong, because if I convert it, first one is 8, second one is still 7. So clearly you can see that it is the leftmost set bits position which determines the value of a number, whether it is higher or whether it is lower. The bits to the left rarely contribute. I hope you're able to think. So if I were to ask you which is higher in value, look at the leftmost set bit. If both the leftmost set bits are equal in the same position, then you will have to consider the right side bits. But if one has a leftmost set bit where the other is 0, this is set, this is 0, which means easily you can tell which one is greater, which will be the first one. I hope these three observations has made sense to you. Now this forms the foundation on which we are going to build the logic. Let me show you. Alright, now let me simplify the algorithm for you guys. It's very simple, guys. Look at this. This is the array. These are the elements in the array. Obviously these elements in array can be represented in binary like this, right? Now what if I told you just by looking at these binary numbers you will be able to predict the maximum AND value pair? Are you curious to know how you will do that? Simple. I am going to have a variable called as result. This is going to have the final AND value pair, and I am showing 5 bits. Now you must understand, I am showing 5 bits. You can represent it in 8 bits, in 16, in 32, in 64. You know it will work for all combinations, right? Either ways, I want to fill this with the binary equivalent of the maximum AND value pair. Right now it is all zeros. See how I will do it. No need for any algorithm and all, just common sense you use. Let's start with 16. If you look at it, 16's leftmost bit is set as 1. Beautiful. Now don't you think that this position has the highest value? This position has the highest value because it is 2 to the power 4, 2 to the power 4 position. I hope you're able to think. Second highest position is this, third highest position is this, like that it goes. Now if you look at this position, 16 has 1. Now if I had to do AND with anything else, should I do AND with 0 or should I do AND with 1? Only if I do AND with 1, I will get 1. Only then if the bit is set, there is some value to it. If it is 0, there is no value to it. I hope you are able to think. But unfortunately, 9 doesn't have the bit set, neither does 6, nor does 13. Which means, can I do AND operation with 16 and any of these numbers? No. Which means ultimately, the final results, first bit, should it be 1 or should it be 0? Obviously it will be 0, because if you do AND, this will be 0. See, this and this is 0, this and this is 0, this and this is 0, this and that is 0, this and this is 0, this and this is 0, this and this is 0, this and this, any combination, 0 only. Are you able to think? So that has to be 0. Great. Now this is over. Now I am coming to the next one. If you look at the next one carefully, you will notice that 9 and 13's bit is set. Obviously, because there are 2 elements, there can be more also, but minimum, since there are 2 elements whose this bit is set as 1, AND operation will result in non-zero. How are you able to think? So clearly, if I do AND operation, right, the maximum, in any combination you do, the maximum AND value pair will have this bit as set, because you can see there are 2 1s here. How are you able to think? Which means in my final result, this must be 1. How are you able to think? Similarly, this bit is taken care of. Now let us look at the next bit. Clearly you can see 2 zeros and 2 1s. So if I end up doing AND operation in all permutations and combinations, tell me, will this bit be 1 or should it be 0? Now those of you who look at 2 1s and say this bit should be 1 are not thinking, because if this bit has to be 1, then the only possibility is AND between 6 and 13. Now if I do AND between 6 and 13, this bit will become 1, but this bit will become 0, this bit will become 0. But we have already established that the first bit should be 0, second bit has to be 1, but here it is 0. So that should not happen. So clearly this combination cannot work. So this has to be 0 itself. Otherwise, you will not be finding maximum AND value. You will be finding minimum AND value. So that will not work. I hope you are able to think. Then this next, so this bit has to be 0. Next bit, if I look at it, obviously there is only a single one. Whenever there is a single one, you can never ever perform AND operation. So this will anyways be 0. Here there are two ones, and clearly you can see these two ones will result in 1. Even if they result in 1, all the previous bits will be the same. So see, 9 and 13 if I do 0, 1, 0, 0, 1, correct. All the previous bits are the same as the result, and the final bit will anyways be 1, so it has to be 1. Now, if you convert that into decimal, clearly you will notice that what you got is 9, and the maximum AND value pair is 9 and 13, which is 9. Did you see how beautifully it worked? Did you see how beautifully it worked? So, this is what the algorithm does. Check if a bit is set. Check if there are more than 2 such elements whose that position bit is set. If if there are 2 or more bits, then you must go and set that bit in result. Now, taking that result must be the same. Now you have to keep checking whether, next bit, what can be added, while maintaining the previous values of the result as it is. Now how will we do it? Simple, guys. Now there are 2 components to this program. Component 1 is to check if a bit is set, and to get a count of how many such elements are there whose bit is set. Based on that count, if that count is more than or equal to 2, based on that you set the value in the result. I hope you are able to think. How are we going to do this? Let me show you. Very simple. First and foremost, I want to check how many elements are there, what is the count of elements in my array, whose this 4th position bit is set. How will I do that? Simple. I will create a mask. What I will do in my mask is, I want to check if this bit is set. So see, in the mask everything is zeros, only that position bit will be made as 1. Now to check whether that bit is set, very simple, perform AND operation. If you do this mask AND operation with the element in the array, and if you get back the mask value, then you know that bit is set. Simple as that. And that is what I will do. And if in case I do that, I will get true. True means I know that I found one element whose 4th position bit is set. That is what it means. So I need to keep track of count. I'll create a variable called as count. Initial value will be 0, but the moment it becomes true, I will increment the value of count, it becomes 1. Any confusion till here? Now what will happen is, this mask is going to move down. Next iteration. With the next element, do AND. This bit is set here, this bit is unset, so you will get false. False means don't increment count. Move it down. Next, check with 6. Obviously, this is set, this is unset. Because it's unset, false. False means don't increment count. Come down. If I come down, I will see that this bit is set, this bit is unset. So obviously I will get false if I do AND operation, which means count for such elements whose leftmost bit is set in the given array is 1. Now what is the significance of that count? That count tells me whether AND operation is possible or not, to give me the maximum value. Now if there is only one element, everyone else are zeros. If I do AND, forget about maximum, I will get minimum value because it will become 0. So the moment I see that the count is not equal to or greater than 2, I will go to my result and I want to ensure that the first bit is set as 0. How will you set it as 0? Don't have to do anything, leave it as it is. Leave it as it is. Don't touch it. So the moment count is less than or equal to 2, don't touch your result, leave it as it is. If you leave it as it is, you know that 0 will remain 0, and that is what you wanted to do. Beautiful, beautiful. Now listen to me. First bit is fixed as 0. Now you want to know what the second bit in result has to be. Now all you have to check is whether I have to set it or unset it. So what will you do? What you will do is, first of all, mask concept only you have to use. Okay. So I am bringing the mask back up. But this mask must change. How this mask must change is that I now know that in my mask, the first bit has to be 0. Now I am checking if the second bit must be set. So the second bit has to be made as 1. Now how will you generate this mask? Very simple. All you have to do is take your result. As of now it's all zeros. Take the mask where you want to check whether the second bit is set. What is the mask to check if the second bit is set? 0. Second bit is 1. Everything else is zeros. I hope it is clear. Merge both of them such that the first part of the result remains the same, and then you're adding this 1 to check. The same, and then you're adding OR. If you use OR, 0 remains 0 only, 1 is added, everything else is 0. That is your new mask. Now do the same operation, boss. Check if this and the first element 16 is the second bit set. No, false means count is 0 only. Come back. Next with 9 you check. Oh, set and set, which means it is true. Count becomes 1. So you found one element whose second bit from the left is set as 1. Bring it down. Next iteration. Check with the next element 6. Oh, 6 is unset, which means false. Count remains the same. Next 13. Oh, both are set. Set means now you know you found another element whose second bit is set, which means increment the value of count. Count becomes 2. Any confusion to this point in time? So you found 2 elements. You found 2 elements whose second bit is set as 1. If you found 2 or more elements, then that means upon performing AND operation, the final result second bit will inevitably become 1. Would you agree with me? So shouldn't we go there and make that as 1? How will we make that as 1? Simple. Take this mask, put it there. Perform OR operation. If you perform OR operation, both will be merged, and you can see first bit remains the same, second bit becomes 1, everything else is zeros as of now. So now it is fixed to me that in my result, first bit will be 0, second bit will be 1. Now what about the other bits? Very simple. Again, perform the same operation. Take the existing value of result, right? After which, take the mask. Now in the mask, third bit I want to check for. That is this position. So that I will make it as 1, everything will be 0. Perform OR operation, in which case you will get 0, 1, 1, 0, 0. And that becomes your new mask, which is what I am also just showing to you here, ladies and gentlemen. Watch it. 0, 1, and I'm checking if this has to be 1. Any confusion? Now, obviously count is resetted because I'm checking the next, this is a different iteration altogether. So here, if I check, okay, 1, it is 0, unset, false, so count is 0. If I come down, okay, here it is 1, but there it is 0, unset, so false, count remains 0. Now I will come here and you can see here it is 0, there it is 1, great, again this will give me false. And if in case I come here, you will notice that if in case I check here it is 0, there it is 1, so again same thing. And please understand, you are not only checking for this 1, you are checking for this 0 also, this 1 also. So the 0, 1 is fixed, to that you have added 1. And is there anything which if you perform AND with, you will get back this? Unfortunately, there is nothing. Count is 0. If count is 0, it means that AND operation cannot be done, and it is working according to expectation, which means that result has to be 0, the third bit has to be 0. 0 means you don't have to touch, don't do anything. Only if you have to set it, you have to do a lot of circus. Don't do anything. So when count is less than or equal to 2, less than or equal to 2, then we must not do anything. If it is greater than equal to 2 only, we must do something. I hope you're able to think. Great, beautiful. So now I can see that my result is taking shape. It is 0, 1, 0. Now what about this bit? Should this be set or unset is the question. So how are we going to check if this is set or unset? Simple. Take the previous value of result. Now you are checking for this bit. So make that as 1, everything else is 0. Combine both of them. If I combine both of them, obviously my mask is going to look like this. So 0, 1, 0, and this one I am checking. Any confusion? Count is again resetted. Now I am checking for this bit, right? Obviously 1, but there it is 0, and see the rest is 0, 1, 0, but here is 1, 0, 0. So this and that will give me back this. Not only depends upon this bit, it depends upon these bits also. I hope you are able to think. Now I will come down, again I will check AND operation, I will get false. I will come down, again I will check AND operation, I will get false. Again I will come down and I will check AND operation, I will get false. Because count is 0, I know that this bit has to be 0, so nothing I will do. Now I will update my mask because I want to check for the last bit, right? So what will I do? Result is the same as that. and the mask, only this last bit will be 1, everything else will be 0. If I merge everything together, this is the mask that I will get. As you can see, till here it is the same as the previous result. Just now we are checking for this bit, which is 1. That becomes my mask. Mask and the first number, obviously false, count is 0. Mask and the second number, oh yes, I have got true. If I get true, count becomes 1. Mask and the third number, false, count remains the same. Mask and the next number, if in case I check, obviously I am going to get true. If in case I get true, count increases, count becomes 2. The moment count becomes 2 or greater, you know that this inevitably is going to result in 1. If this is going to result in 1, then 100% our result also must have 1 in that bit. Any confusion till there? If it has to have 1 in that bit, what should you do? Very simple. Take this mask, perform OR. If you perform OR, that new value becomes your result, right? And there are no more bits left out, so I stop. If in case I stop, look at the final value of result. I am showing the powers of 2, and if I convert it, you got 9. It is as simple as that. Beautiful, isn't it? So 2 components. Checking the count of set bits for a particular position, and then based on that count value deciding whether to set a particular bit in the result or not. How do we do this as code? Let me show you. Now writing code is the easy part. Okay, look at it. Ultimately, I've hard coded my array here, so the scanner n and all is not really required. You can just remove that. So you can write, I'm sure by now everybody knows how to take input from the user. I'm just hard coding it to save time. Now there are 2 activities here, right? One is for every bit you will have to check how many bits, how many numbers have their bits set, that count you want, right? So what I will do is I'll go on top and I'll create one static function which gives me count. So static int, I will call this as static int. I'll call that as, check bits. I'll just call it as check bits. Great. So this will accept my array, basically it will accept my array. So I will just pass my array. I'll call it as integer array AR. Yeah. Also it will accept the mask, because I obviously need the mask also. And yeah, pretty much that's it. Now I'll come inside, make the brackets proper. Now what I'm going to do inside this is a very, very simple thing, guys. Here I'm going to go and I'm going to start my coding, right? So what did we do to check the thing? We created a mask like this. We took the mask, performed and checked whether we got the mask back. If it was true, we incremented count. So I'm just creating one integer variable called as count. Initialize it to 0. Great. Now what I will do is very simple. I need to iterate over the array. So I'll put a for loop. So for int I equal to 0, I less than a dot length, array dot length, and I plus plus. Now inside that I will go and very simple. What I will be doing here is very simple. Here now just check if in case I do AND operation between my mask and the element at the ith position. I will check if this is equal to my mask, if it gives me back my mask. If it gives me back my mask, I know that the bit is set, and I will just increment the count. So I'll put it within parenthesis, yeah. I'll just increment the count. Ultimately, when I come out of this loop, it will give me the count of all such elements whose bit was set. Now we are able to think. Any confusion till here? And to check which bit is set, mask is used. So mask will take care of checking for the bit. I will return count. Return spelling. Yeah. Good. Now at the end of this, this is my first activity which I'll have to repeatedly use. Now I'll come outside and I'll create my function which will actually give me my max and value, right? So I'll just tell static int max and value. This will also take my array, and only my array it will take as input. Okay, good. Now what I will do inside this is very simple. First and foremost, we require mask, right? So I'll create integer mask whose initial value will be 0. Initial value will be 0. I also need my result, which also I will initialize it to 0. Okay, so see, now what were we doing? Ultimately, we were iterating over the bits present inside every single variable. I hope you're able to think. So one is that you should be able to iterate over the array, and as you're iterating over the array, for each element you should be able to iterate over the bits. Now all we have to do is create this result, right? As of now everything will be 0. Now you should know what to set here. Now how did you decide how to do that? Very simple. You created a mask, you sent that mask to check bits. Check bits will iterate over the array, and for every element it will check whether that bit is set, and it will give you the count of the number of bits which is set. Based on that count, if it is greater than or equal to 2, you will decide whether to make this 0 or whether to make it as 1. So what's the duty here? One is to create the mask. Second is to, based on the count, update the result, which is what I am also doing. So first you need to iterate over the bits. See here, bits is from 4 till 0. I need to go like this. But because we are dealing with an integer array, integers means they have 32 bits. So see, I'll tell for, and from leftmost you have to go. So leftmost bit is 31. And it should go till 0. And it should decrement in value every time. That's how you go from this bit to this bit. I hope you're able to think. Next, inside that, very simple. What should I do, guys? First I should prepare my mask. So see, mask I already declared. So I'll tell mask equal to, okay, whichever is I value, that is nothing but bit. That bit I have to check for. So how will you do that? I'll take 1, left shift it I number of times. That's how you will create the mask. Now this is the mask, but if you look at it, every time we updated the mask by doing OR operation with result, isn't it? First time also you do it, it will not make any difference because anyways result is all zeros. So I will tell OR with result. I'll be able to think. This is your mask ready. Next I will come down, and now I should call, scroll on top, I should now call check bits. Check bits will return the count. Based on the count, I should update my result. That's what I will do. So I'll come down, scroll down. Yeah, fine, no problem. Check bits I will call. So check bits, I'll pass my array and I will pass my mask. What will it return is my count, which I'll collect in an integer variable called as count. Okay, fine. Now scroll on top. So what will you do with this count? Now if this count is greater than or equal to 2, you now know that you have to set the result, that bit in result, as 1. So I'll just check if in case, simple, I'll check if count is greater than or equal to 2. If count is greater than or equal to 2, then I am going to set it. So how will you set it? You know, I'll tell result is equal to result or with the mask. This also I have explained. Any confusion till this point of time? I hope everybody understood. Ultimately, this operation will keep repeating itself, and when I come out of this loop, I will have my final result, which I'll return. Good, great. Now let's just execute and check whether it works, right? So if in case I execute it, clearly you can notice that we didn't call, so nothing is coming. Let's call. So I'll just tell sysout max and value, and I will pass the array. Good. Now if I just execute it, clearly one can notice that if I give nothing, it is not returning anything. Yeah, it has returned 9. Okay. So obviously, you know, it is 9 and 13 which is the maximum AND value, and that is what you have got. Any confusion till here? So perfectly it works. So I hope all of you enjoyed this logic. Ultimately, this operation is iterating over the bits. Whenever you iterate over the bits of a decimal value, I've always told you it is big O of log n. Any confusion till this point of time? And if I scroll on top, this is iterating over the entire array, which means this is big O of n. Now I have big O of log n, I have big O of n. If in case I add both of them together, then I will get n log n, like that I will get. Any confusion till here? Which is still much better than n square. Anyways, I hope Microsoft selects you. I hope you practice enough for Microsoft to select you. Let's catch up in the next class.